All right. All right, so on your warm-up, you were supposed to decide if it's linear or if it's quadratic. What do y'all say?
It's linear.
Okay, so if it's linear, then they have a constant rate of change, right? Looking at my x's, from -3, -2, -1, 0, 1, 2, 3, constant rate of change of 1, right? Your y's. How about 9 to 4? That's down 5. How about 4 to 1? Down 3. Uh-oh. 1 to 0, 0 to 1, 1 to 3, and 4 to 9. So my first difference was not the same. But what if you did it again? Remember doing this? How about -5 to -3? That's up 2, right? -3 to -1, up 2, up 2, up 2, and up 2. Okay, so because of this, your second difference was the same. So does that make it a linear or a quadratic? A quadratic.
Wait, I thought if it was the same, it was linear. Oh.
If the first differences were the same, that'd be an x to the power of 1. That's a linear function. Your second differences match. That's x to the power of 2. That is going to be, I also can't spell difference. There we go. So the how do you know? You should say the second differences are the same. That's the how do you know. Okay, linear or quadratic, it is quadratic. How do we know? Because your second differences are the same. Okay, then it says use technology to write the equation of best fit. Okay, we've done this before. You got to make a list, an L1 and an L2. Remember this, maybe? Yeah, you push your stat button. You push enter. And we make our list. So list 1 is -3, -2, -1, 0, 1, 2, and 3. And then your second list or your y values were 9, 4, 1, 0, 1, 4, and 9. Do you remember how to get the equation that matches this? So we know it's a quadratic. To do quadratic regression, go back to stat. This is going to come back up today. So I really hope you know how to do it because I'm not going to tell you how to do it later. So after your lists are in, you go to stat. We want to calculate. We said it was a quadratic. It's not a line, right? If it was a line, we would do 4. It's a quadratic, though, we're going to do 5. Click enter here. That's what we stored. And calculate. What's the quadratic equation? Y equals x squared. Doesn't that make sense? Look, -3 squared, -2 squared, -1 squared. That makes sense. It was the parent function. Okay. So this is old news. You've done this before. Okay. Everything we've done in today's section, which is the last section of chapter 4, you have done before with quadratics. We are going to do them now with cubics and quartics. Okay, so that was a quadratic regression. I don't know if you notice, back on my list over here, there's also a cubic regression and a quartic regression. So those are the ones we're going to use today. Okay, something else that's on here that we've done before is I have given you a parabola and told you to write the equation where you had to find A. Right? I either gave you 2 intercepts or I gave you the vertex. And then you had to use another point to write the equation. Remember doing that? Yeah? Okay. We're doing that today. That's our first examples, but we're doing with cubics. Okay? So everything you're doing today, you've done before with quadratics. A cubic function is going to have how many solutions? 3. It's a cubic. Has a degree of 3. Okay? Do I have 3 solutions shown to me in this graph? 1, 2, 3, right? They're labeled for me. So how am I going to put those back into factored form? You do. It becomes x plus 4, x minus 1, and x minus 3, like that.
When am I going to need this?
The test is Friday. Okay? What we're missing is the a value. What we're missing is our a value. So we need to be able to plug in something into x and y to find what that a value is. Well, guess what? They gave me a point of 0, -6. So 0 is going to be my x. -6 is going to be my y. So -6 equals the a that we need times 0 plus 4 times 0 minus 1 times 0 minus 3. So what is 4 times -1 times -3? That gives us 12. Solve for a by doing what? There you go. Divide by 12. And we get an a value of -1/2. Does your math make sense? Does it make sense that we got a negative value for my a? A is your leading coefficient, right? Would it make sense that my leading coefficient is a negative number? How do you know that? Because it's going down. It ends in the negative direction. So make your math make sense. Everything we learned about, it all comes together. It makes sense that I have an a value, a leading coefficient that's a negative number. Okay? And now I have everything I need to write our function. Okay? So we're going to do f of x equals, maybe, there we go, -1/2 times x plus 4 times x minus 1 times x minus 3. Yeah, this is factored form or intercept form. If you were asked for standard form, you would do more. You would multiply, distribute, that whole thing. But I am confident you can multiply from here on if you had to. All right. What does the next one say? You try. It says you try, so I want you to try. All right, so again, just like last time, you do have 3 intercepts. And you have 3 x-intercepts, and they also gave you the y-intercept. You're going to get to use all those pieces to find your function. When you are ready to check, look up here. Does my math make sense to have a +2 for an a value? Yes, because my cubic function ended in the positive direction. What's that?
Why did the x's, like 1 and 4, change to negative?
Because you're putting intercepts back into factored form. You got x equals 1, x equals 4. So to put it back into factored form, you're bringing it back over with the x. So it changes its sign. Yeah. Good question. All right, we're going to level up. So how do we feel about the graphs before we move on to tables? We're okay?
Yeah.
Okay. Do you remember doing this with the quadratics? Yeah? Okay. All right, with my tables. Okay. Here we go. Use finite differences to determine the degree of the polynomial function that fits the data. Then use technology to find the polynomial function. Okay, so we're going to do what we did in my warm-up. We're going to find our differences. You ready? Why does it keep doing that? There we go. All right, so my differences, so look at my x's. 1, 2, 3, 4, 5, 6, 7. They're good. They're all the same. Okay, that's important to notice that they are all increasing by 1. Now I can focus on my y's. Okay, how does negative 3 become negative 9? Down 6. All right, negative 9 to negative 14. Down 5. Negative 14 to 0. Up 14. 0 to 63. Up 63. 63 to 217.
Up 152. Oh, wait,
4.
54.
It's okay. 217 to 516. 299. I'm sure it probably fits better on your paper. Are those the same?
No.
Nope. So is my first difference the same? Nope. We got to keep going. So that means it's not what function?
It's not a linear.
It's not a linear function. So now let's try my second difference. Okay, let's try our second difference. Negative 6 to negative 5.
1.
Up 1. All right. Negative 5 to 14. Up 19. All right. 14 to 63.
Up 49.
There you go. 63 to 154.
Up 100.
Almost.
I meant 99.
91.
91.
217. I lied. 154 to 299.
145.
Good. Are those the same? No. So it's not a quadratic. All right. So let's do it again. Let's try our third differences. How about 1 to 19?
19.
Careful. 18.
Oh,
19 to 49. Up 30. 49 to 91. Up 42. I heard it. Thank you. 91 to 145.
103. No.
Or 54.
Oh.
Was my third difference the
I was
same?
looking at 49.
No. Whew. We got to do it again. Hopefully this works.
Nah.
What about 18 to 30?
Like 12.
How about 30 to 42?
Somewhere around like 12.
42 to 54?
Probably 12.
Woo! Okay, so what's the degree of this function? 4.
What does that mean? That seems hard.
Our degree is 4 because our fourth difference was the same. So we are going to use quartic regression.
Oh, that does not sound good.
Okay, we're going to use quartic regression. So we're going to do exactly what we did in my warm-up. But when I calculate the best equation, we're going to do quartic regression instead of linear or quadratic. Okay, so open our calculators, go back to our stat, edit my list. Remember to clear your list. Oops. I know. There we go. To clear your list, just stat and then list. To clear your list, highlight the L1 or L2, click clear, and then go down. Clear and then down. And then we're going to do our new values. So we have 1, 2, 3, 4, 5, 6, 7. Whoop. Y'all didn't tell me I skipped one.
Wait, how do you clear it?
You highlight the L1 or the L2, push clear, and then push down. -3, -9, -14. Yep. 0, 63, 217, 516. Yep. Once your data is in, you push stat again, go back over to calculate, and then we said we're doing a quartic regression. So it's option number 7 now for quartic.
Wait, then once I have this, we hit enter.
Push stat again and go over to calculate.
And then
Quartic. Yep. Use the list we gave. We're going to calculate. Yeah, it's something weird, right? So we have 0.5 x to the power of 4. Yes. Minus 2x to the power of 3. This is 0. And then 0.5 and then -2. These are coefficients, okay? That 5.4 times e to the -11, that means move your decimal backwards 11 times. It's just going to be 0. Okay? So let's go back here. So f of x equals, we have 0.5 x to the power of 4. Then it said -2, so that's -2 x to the power of 3. We technically don't have an x squared. So you can skip it or you can say plus 0x squared. It's totally up to you what you want to do. They're both correct. I personally, mathematically, am going to skip it. 0 means it doesn't exist. It's not there. Okay. Then it said 0.5x. And then we ended it with the -2. Okay. So if you have a plus 0x squared in the middle, you are fine.
So the D is the part for regular.
Yeah. Yeah, so like A starts with the quartic. A starts with the 4, and then it goes 3, 2, 1, none. Yep, it goes in order from there. Yep. Like you would if it was synthetic division, it goes in order like that. All right, think you can do the next one? Okay, yeah, the next one is a list of values, but which ones do you care about? The y's, right? I mean, always double check your x's. They goes 1, 2, 3, 4, 5, 6, 7. They're fine. So now you're just worried about your y values. So you do the next one. I'm going to do it quietly. I will do it, but I'm not going to talk. I'm going to do it silently, so that way I'm not distracting people who are trying to do it by themselves. Okay? All right, when you're ready to check yourself, it is up there. This time when you did your differences, you had to do it 3 times. Your third difference was the same, which made this a cubic. So my degree is 3. So when we put in our L1 and L2, the test you're going to run or calculate is going to be a cubic regression. You get an A of 2, a B of -5, a C of -25, and a D of 0. That means that there's a constant of 0. So if you want to put +0 on the end, you can. You do not have to. The back is real life with animals.
Wait,
The back.
like a fish.
There's a fish. There's also an eagle.
I don't care about the eagle.
It's a largemouth bass.
What would you name it?
Yeah, it's fine.
The fish?
The eagle.
Goldie.
Oh, I don't know.
That's a big one for a
I don't know.
dog.
There's some that like
That's
makes
what
up.
The eagle is Goldie?
Yeah.
I don't know.
Like Susan.
Susan. Questions about the one that we just did together? So again, it should be old news because you've done it before, just we haven't gone this far. We usually just said linear or quadratic. This time we're finally extending it to cubic or quartic. Okay. Now, with real life data, which is what's on the back, you can't use differences. Okay? Because real life isn't perfect. Okay? It's not going to work that way. Okay? So in examples 1 and 2, we found a model that exactly fits the set of data. Okay? In real life situations, you cannot find something that fits exactly. Okay? But we can still use technology to approximate, okay, a model to fit the data that we have. Okay, so my first one we have is the data shows the number of active bald eagle nests in Florida T years after the year 2000. Find a model for the data and then use that model to estimate the number of active bald eagle nests in 2018. Okay, so we're not going to find our differences. We're going to go straight to our calculator and put in L1, L2. Okay, something else is going to show us a trend. Before that happens, put in your new data. Here goes 0, 2, 4, 6, 8, 10, 12, 14, 16, and then 20. It skips 18, so watch out.
Why does it keep turning?
9, 10, 92, 11, 66, 12, 78, 13, 62, 15, 11, 14, 99, 15, 68, and 1500. What did I skip? All the way up here. All right, cool. Y'all should have plenty of time to get all your data in here. Because what we're going to do is we're going to make a scatter plot. There we go. Okay, so scatter plots. Let's remember how to do this because, again, it's happened, but it's been a while. Okay, so instead of y equals, you're going to do second y equals. Second y equals. I want to turn my stat plot on. So push enter and turn it on.
How'd that go so fast?
I did second y equals, clicked enter, and then you probably click enter again to turn it on.
Okay, there we go.
Okay. It shows that it's doing a dot plot, that it's doing a list 1, list 2. Okay. If you go to graph right now, though, you're not going to see it. Okay. We're going to change our window. But look, your table tells you what window to use. Okay. look at your t values. They go from 0 to 20, right? So let's go to my window. Let's change that. Let's say 0 to like 22. Okay. My y's, nothing is negative. We get, what's the highest number? 1568. So let's go to about 1600. There we go. So my x's go from 0 to 22. My y's are going from 0 to 1600 because it makes sense with the table that was given to me. Now push graph. Now you should see your points. And it looks something like that. Okay. Looking at this. Oh, window.
Oh, window.
Yeah, window. There you go.
And then you did 1500.
0 to 22 for your x's. And then y then 0 to about 1600. Okay. So looking at this, it's not a line. It's not a parabola. It's going to be a cubic or a quartic. Which one do you think is going to be the best? Cubic, quartic? Not sure? Let's try cubic. Okay. If you're ever not sure, it's okay. You're going to test cubic, and then if you don't like it, you can always test quartic. Okay. You've already done the hard work. All your data's in here. Okay. So let's do stat. Calculate. Let's calculate the cubic regression. Okay. Round to about two or three places on my paper. I did 2 places. Okay. So we're going to test this. We're going to test this. How am I going to test it? I'm going to put it into y equals. Okay. So in my y equals function, I'm going to do negative 0.27x cubed plus 7.27x squared minus 17.62x, and then plus 1088.86.
What we got that one?
X to the power of 3. We got to test it, though. 62x. And then plus.
It doesn't hit all of them. Okay.
Right. Yeah, it won't be exact because it's real world data. Yeah, so once you put that into y equals, push graph. Does it fit? That's a pretty good fit.
So that's the answer.
Oh.
That's the answer.
So this is our model. So when it asked me, so what we did first, so make sure you do like a little note to yourself. You did a scatter plot because we can't find differences. So we did a scatter plot. You can even sketch it if you want to. Kind of looks like that, right? When we did it in our calculator. From here, we were like, is it cubic? Is it quad? Is it quartic? We assumed cubic first. We tested that and we liked it. Okay, it definitely fit. So this is going to be a cubic function. Negative 0.27x cubed plus 7.26x squared minus 17.62x plus 1088.86. There we go. So that was, it said find a model. I did it. That's the model. Now use the model to estimate the number of active bald eagle nests in 2018. So it wants me to find f of what? Of 18, because it's t years after 2000, right? So 2018 would be 18 years afterwards. Okay. Now instead of plugging it in, friends, watch. I'm going to calculate the value for 18. Second, calculate the value when x is 18. Boom, 1549.3. Okay. Or go to your table. You can always go to your table and find where x equals 18. It does the exact same thing. Okay. But again, to show you what I just did. So above trace is calculate in blue. So I did second, the trace button. I clicked enter on the value. And then the blinky is next to x. It wants to know what x value. I want the x value of 18. And I pushed enter. And it told me 1549.3. Okay. You can also go to your table, which I know you're familiar with. And you can scroll down here until we get 18. And it's the same thing, 1549.3. So a couple different ways to get that value.
What if mine doesn't go inside?
So 2018 had about 1,549 nests to answer their question. Okay, so this is the model. This was part 1. And then we evaluated for 2018. In a minute.
That was a lot for one.
I know, right?
Can we not do the next one?
You have to do the next one.
We have to?
Yes.
Okay. And we have to do it on our own.
So my next one shows the numbers of largemouth bass used to stock a small lake T years after 2012. Find a model for the data and then use the model to estimate the number of largemouth bass used to stock the lake in 2020. So you're going to put your data in first. Do second, trace or calculate. Value, push enter. And then type in 18 and push enter. Just go over and push 8. There you go. And then enter.
Wait, you did 4.
There you go.
Okay.
Yep. You're good.
Wait, how do I get a different one?
You might have done it a little bit differently than me.
Oh.
There you go.
What did you do?
Wait.
All right, this one goes 0 to 7.
Okay.
This one looks a little odd, right?
Oh, 1, 2, 3, 4, 5, 6, 8.
Just a little.
Yeah, because it's like.
Do you have to probably change your window?
I think it's just really small.
So yeah, it probably is all showing up, but it's probably really small. Thank you. So we are going to fix my window so it matches with our data to give us a better picture. 410, 856, 850. Okay. So to fix your window, my X's don't need to go to 22. They can just go to what?
I don't know what.
They can go to 10, 8, 7. I wouldn't stop on the exact value. I would do at least one beyond. Okay, so window, I'm going to have them go from 0 to 8. My Y's, the most is what, 856? So what do you want to do? 860? Okay. And then push graph, and then you'll probably see it better.
I don't see
The window? So 0 to 8.
how.
And if you ever want to zoom out, I mean, you can make this 900 if you want to see a bigger picture. So your window is 0 to 8 for your X's, and then 0 to 900 for your Y's. It's also on the board above me. For your window, push graph, and there's our points. So it's kind of an odd shape. We're not sure if it's cubic or quartic, right? So we are going to test both. Okay? We're going to test both, and I'm going to help you. I'm going to go ahead and tell you what they are. But I'm going to show you how to test both of them. But watch, because when you do one, it like kind of maybe might work. Just stay with me. Stay with me, okay? For time's sake, I'm going to give these equations for you, okay? So we're going to test cubic and we're going to test quartic, okay? Your cubic function is -3.16 x to the power of 3 plus 61.61 x squared minus 152.24 x plus 59.21. All right. So again, -3.16 x cubed plus 61.61 x squared minus 152.24 x plus 59.21. So that is our cubic function, okay? I also want to test my quartic. Why do I want to do that? Well, let's go ahead and look at this. So like it kind of matches, right? But I do have some points that are kind of far away from it, right? So like I don't love it. So we can always test our second option, okay? So let's test our quartic function. See if it makes it any better. If it's not any better, then we'll go back to cubic. Okay? Your quartic function is going to be -5.17 x to the power of 4 plus 69.19 x cubed minus 252.14 x squared plus 271.51 x minus 2.8. All right, and then graph that one. Is that better?
Yeah.
Yes, I would agree that this line is definitely fitting better with my points. Okay, it even rises up a little bit. It goes back down. It rises. It dips again. Okay, I would definitely say that the quartic regression is better than the cubic regression. Okay. So you're allowed to test more than one and do it on the same plane and compare them to each other. Okay. So we like quartic. Okay. What value are you going to test, by the way? If it wants to know in the year 2020. Why is it 8?
Because it's years after 2012.
Good. It's years after 2012. So we need to evaluate this for 8. What do we get when we evaluate for 8?
I'm gonna guess.
Don't guess.
About
Lovelies. Remember? We can find our value. It's for 8, right? Is it the 1,166 or is it the 281.28?
That one.
Yes, 281.28. So we're going to say about 281 bass are used to fill the lake in the year 2020. No, it was not. It was not. Okay. So a lot of calculator work. We will definitely practice this tomorrow and do more with big ideas. And then we'll do 2 days of review for chapter 4, and then we'll test on Friday.